Hey guys, I am pretty much done with all the individual assemblies. I did go ahead and replace the original resistors, and I tested the mica caps and they all seem to be good, so I left them alone. I cleaned up all the contact points and lubed up the controls. I left this carbon level control in place. I did use a little bit of fader lube on a Q-tip and went over the carbon surface. I'm going to leave the back of it off now until I make sure it's working properly. So time has come to put it all back together. Power supply I've remounted to the back plate here. Probably easiest to work on if I position it like so, I think. This is going to remount, I believe, like so. And this goes in somewheres up in here. And band switch, I think, goes down here. So, this is where reference photos are really indispensable. Schematics only get you so far, because sure, it can tell you what's connected to what, but when you get a 3D puzzle like this, especially if you've gone and taken it this far apart and you've spread the project over a matter of days or weeks, so you can't quite remember where everything went, really good to have a bunch of photos. So I not only have the video that I made while working on this, but I took a whole bunch of reference photos. So for example, I know that this is that. So if I position this like so, kind of how it is in the photo, that this switch part, orient it the same way, which I believe is like that. If I put it kind of down like so, I should be able to start hooking this stuff back together. So what I want to start out with is to marry these two back together, and I have one cap to replace, and I'm pretty sure it goes in between these two. So you can see in the photo there was one paper cap down there. That is this one I've replaced. There was one in between the switch ducts over there. I replaced that, but there's one more. So it's not that guy. And it's not that guy. I think it was that one. Or that might be the same as that. See, I know I don't see it because I already took it out. So those two, those have been replaced. I took this to show me where all the screws and washers go in the back plate. And here's one I took before I did anything. That will definitely be very useful in the final steps. The other tricky thing to replace is that guy. This. Because it has these contacts up here which are used for tie points. They don't actually go to anything, I don't think. On this control, I could be wrong about that. Oh yeah, now I remember. Okay, yeah. So that is the power switch, as indicated by this dashed line here. But those other three elements, I'm sorry, they are used. They're not they are used for tie points, but they do also serve a function. That is to enable or disable the modulation. So there's a bunch of stuff that hooks up to them, including several points on the tube, heat supply. So it goes to this rotary switch, or that cap on the rotary switch over there. So yeah, bunch of stuff going on. Alright, so yeah, I didn't want to take it apart this far, but I really didn't seem like I had a choice. Now, I know somebody else on YouTube, I'll try to remember to include a link in the description, who also got one of these about the same time, and he restored his. And from what I saw of his video, I don't think he went quite as far with having to take it all apart. But his is working, so it's also a valuable resource, is to go onto the Antique Radio forum or search on YouTube. Find somebody else who's worked on one and restored one. Check out their photos, check out their restoration diary if they posted one. Alright, so I will continue to look through these photos and hook things back up as best I can. Finally, things are really coming together. So, the missing cap, I couldn't quite figure out where it was, because I clipped it out early on, as near as I can figure. Goes between that mode switch and one part of the switch way down in there. So I used a long axial lead cap. And the other couple terminals here are pretty easy, just to make a cap and a small value resistor, so that connected those up. I still have a few wires to go to this. And then there is the variable capacitor. And probably the trickiest thing so far has been the wire going to the variable cap goes up through the hole in the top here, and it's not that long. I don't want to replace the wire because it's in pretty good condition. Which leads me to the cap, which I'm going to remount right now. So all nice and clean and rebuilt. That amounts like so. Well, like so. And if you recall, when I took all this apart, kind of heard some little bits falling, as one of you left in a comment, and I noticed that there were some standoffs that had fallen out. These three in particular. Well, those hold the cap on, and here's again where reference photos come in handy. That would be these, the ones that have washers, and there's the cap shaft sticking through. Now that variable cap only has a few connections going to it, so I can remount it without connecting anything to it. So that's what I'm going to do right now. So here are screws with the washers on them and standoff. And this goes here. And the connections on top. One of them, this guy with the 47 ohm resistor on it. That is actually the output. It'll be a little tricky to get all of these in at once. There's one. Second one. Hindsight, I should have remounted this before the power supply, then I'd have easier to manipulate things. But even so, it's not too bad. So there's number 2. Get in there. Alright, one left. Here. Of course, I need to tighten them all down. Now, one little lug right there, that is what this wire connects to. Now, the one thing I don't want to do is prematurely remount this and hook this up. I want to make sure I've connected everything back down here. So this whole assembly goes up in like this. I'll take this knob off. So the shaft will go through the metal plate. So you see there's some wires down here. Those need to hook up primarily to this switch, I believe. And this wire, I'm pretty sure is the filament supply for these two tubes. Otherwise, I think everything's connected. Yeah, I think we're in pretty good shape. So unfortunately, these lugs that still need to have wires connected are kind of up in there, so when this is remounted, they're pretty inaccessible. So I have to try to reconnect them before I put this all back together. Maybe like this will be a little bit easier. Kind of get things situated about where they will be in their final resting place. Also need to remember to reconnect this. This is the cap for the 6J7 grid cap. It goes on the variable capacitor up here. Or actually this side. Alrighty. I think that is everything. I had made one mistake. Big mic cap down there. I had connected up here, but it's supposed to go down to the lower deck. I replaced one of the original wires here. There was a long resistor going from here over here, 500 ohm. I strung together a 220 and a 270 to give me 490, close enough. And I needed the extra length on it. I forgot to put some heat shrink tubing over it in the middle, but I don't think it's going to be near anything, so I don't think it's going to be an issue. As I said earlier, this is a filament supply, and this goes to the variable cap up here, so I think that is that. So, I'm going to flip this up and remount it, hook in, I think this is the only wire, this one I already reattached, that goes to the supply. This whole section over here only runs on for this supply point here in the power supply. Tap between the two bleeder resistors. So there's really very little that connects this to this. And then, well, I guess it's time to try firing it up. And I'm going to do it without this. It's not necessary, so I've got everything installed up to this point. That's 45,000 ohm resistor is this 47K I used up here, so this right here is the output. So I should be able to check that without the attenuator in place. So just be a few minutes, we'll hook some stuff up, and then fingers very firmly crossed that it's working now. It's all back together except for the output attenuator. I've got a scope right on the output, and I'm about to plug it in, or I should say turn it on. I do have it plugged in. Can't quite tell what position the controls are in because I don't have the panel on. I think it's off. Let's see what happens. There's no current draw. There's the output voltage for 117 on my PR57. Alright. Here we go. Current draw seems reasonable. Filaments are lighting up. We have something. Looks like pretty low frequency. Looks like it is modulated. Digital scopes aren't the greatest thing for doing this kind of stuff, but that's what I have handy. I have no idea what band I'm on. I'll try varying this. Let's see, I'll try to do this up without modulation. It'll be a heck of a lot easier to see what's going on. So there we go. No modulation. Excellent. I'll kill the lights a little bit more. take a closer look at the scope. In case you're wondering, it's a Hewlett-Packard p5o6 dual 100 megahertz digital sampling scope from the early 90s. This is the model I used in college. It's just kind of a lucky coincidence that I happened to find one inexpensive on eBay. That's why I use it. I do have several analog scopes, but this is kind of my go-to because it's got the auto scale button, which you just push and it sets everything up so you can see a waveform cleanly. Another nice feature, if you do time, frequency, it tells you it has a built-in frequency counter, so that is about 140 kilohertz. And let's try turning the variable capacitor. Oh, look at that. Now notice the amplitude varies. Well, that's what you get with a two-tube RF generator. Actually, just one tube, really, because one of the tubes is for the audio oscillator and one tube is the RF oscillator, and of course you have one tube for the DC power supply rectifier, but no voltage regulation, no output amplifier. It's just picking the signal right off of the variable capacitor, actually. But when you're aligning a radio, it's not really an issue. So let us try a different band. I guess that'd be a higher band. Go the other way. So I seem to die. I think this is the audio range, actually. This might just be a really low frequency. Let me get the control panel, see what that lowest position's for. Refresh my memory. Oh, yeah, that is the audio. So here's the control panel. So I am putting the band switch. I'm on the A, the audio. If you do audio with modulation off, this is probably what it's going to do. So I think modulation off kills the plate supply on the audio oscillator, so I wouldn't expect audio out to work. Modulation off, so let's turn modulation on. And now we have something. Auto scale frequency 400 hertz roughly. That would be in the audio range. And yeah, I kind of suspected this. It does not change. It's fixed frequency. So it's just a test tone. And if you look at alignment info on early radios, they very typically specify 400 hertz for the AM modulation frequency. So that all makes sense to me, knowing how these are used in practice. Alright, let's go back to the lowest band. So now we're on the A band, which is 120 to 350. And I do have the modulation turned on now. Again, difficult to see AM modulation on digital scope because it doesn't quite know how to sync. I will try to see if I can get this thing to trigger better. It's been a while. Oh, there we go. Oh, I lost it. There. It's probably about as good as I'm going to be able to show you guys what the AM modulation looks like. So it's not modulating it extensively. I don't know, what's that? 30% modulation, maybe? Something like that. So it's being modulated with that 400 hertz audio, and then the higher frequency would be the RF, and the trigger again got messed up. Alright, let's go back to modulation off and check out the other bands. Auto sync, let's do time again, and frequency. So we're topping out at about, yeah, supposed to go up to 350, or 342 roughly. And at the other extreme, 9112. Yeah, that's about right. So let's try the next range up. So 340 and goes up to about 1 megahertz, which is exactly what it's supposed to. I'm going to just jump through the rest of the ranges. Yep. Notice the amplitude is dropping as we go to higher frequencies. That's exactly what I thought would happen. Again, no output amplifier, no voltage regulation. That's the effect you're going to get. Next range up. Again, amplitude dropping. Now we're at about 7 megahertz. And it's going to top out around. It's having a little bit of trouble figuring out the frequency. Let's see, this should be going to 11 megahertz. That's right about where we're at. Now this top range may use harmonics. It's supposed to go from 11 to 35. By harmonics I mean it might look a little ugly. Nah, actually it seems to be the fundamental frequency. It's kind of pushing things for just a single tube 6J7 type oscillator, but yeah, it's a little jittery. But we are getting to 37 megahertz. And down to about 12 or so. Alright, so this does indeed seem to be working. And it's working as I expected. The higher frequency, the lower the output amplitude, and the flakier it gets. Yeah, but honestly, I would not use something like this to try to align something at 35 megahertz. It's not really where its sweet spot is. It's going to work better down around, like say, 455, which is where I would typically use something like this to align an AM radio. So then you get the joys of trying to dial in exactly 455 with an analog piece of equipment, and it's kind of around there somewhere. So it's a pretty nice clean looking sine wave at 455. Cool. Well, the hour is getting late, so I'm afraid there's going to be one final installment, which will be me putting this all back together, making sure the output attenuator is working like it should be. I'll throw a fuse in here somewhere. Remember, we've got that power line filter on the other part of the case. I got to hook that in and see about getting a line cord that will plug in to the socket that's on the case. But otherwise, hey, it's looking pretty good. The crossed fingers did the trick.